Welcome. In this video we'll be graphing trigonometric functions, Sine Part 3. Example. Use a graph of the parent function shown below to sketch the stated function using radians. Also, find the amplitude and period of the function. Here, our function of interest is y equals sine of 2 theta. So let's go ahead and figure out what is the amplitude. Recall that the amplitude is the distance between the midline and the maximum, or the distance between the midline and the minimum of the function. In this case, we're going to find the amplitude by taking the absolute value of the coefficient of sine. Notice that sine has a coefficient of 1, which is implicit in there. So we take that the amplitude is the absolute value of 1, which happens to be 1. In terms of the period, one finds the period as the period of the parent function divided by the absolute value of the coefficient of theta. Here, since we're dealing with sine of 2 theta, we take the period of sine, which is 2 pi, and we divide that by the coefficient of theta. The coefficient of theta here happens to be 2. In absolute value, we need to divide that. So we do 2 pi divided by the absolute value of 2, which is 2. And that gives us that the period of this function, y equals a sine of 2 theta, happens to be pi radians. So if we were to sketch the curve, if we were to sketch the graph of this particular function, instead of going from 0 to 2 pi, to get a whole revolution or the graph for a whole period, we're just going to go from 0 to pi this time. So I'm going to go from 0 to pi. Now let's go ahead and analyze a few things based on the parent function. If we were to go for a whole period, we can say that we can start at 0 and we can stop at 2 pi, because that's going to give you the graph for a whole period. Now notice that I'm going to refer this one as my beginning, and this point will be my end for the whole period, okay? Now halfway there, I'm going to call that my midpoint. Okay, so those are three important values here, and those are 0, pi, and 2 pi. Notice what happens at the beginning, at the midpoint, and at the end. Here I have a 0. So in this case, and I also have a 0 here as well. So we were to go from 0 to pi to get the whole period, or the graph for the whole period. We can say, well, at the beginning I'm going to have a 0, at the end I'm going to have another 0, and halfway there in the midpoint, which here happens to be at pi over 2, I also have a 0. Now what happens halfway between the beginning and the midpoint? Namely here at pi over 2. Notice that you reach your maximum of 1. So halfway between my beginning and my midpoint, I'm going to reach a maximum of 1. And in this case, halfway there is pi over 4. Lastly, what happens between the midpoint and the end? Well, halfway there, I get my minimum of negative 1. So here, between my midpoint and my end, I'm going to get my minimum of negative 1. And that's going to allow us to do a quick sketch of our function. Now notice that this replicates again. So if we were to start at pi and go for another whole period, okay, or another whole revolution, you're going to go to 2 pi. So now this is my beginning at pi. This is my end. So I had zeros at my beginning and my end. And halfway there, at 3 pi over 2, I also have a 0. Halfway between my beginning and my midpoint now, I have reached my maximum of 1. And halfway between my new midpoint and my new end, I reach my minimum of negative 1. So you can continue sketching this function here like this. And we will just continuously put arrows here because this continuously repeat. And this is the quick sketch of your graph for y equals sine of 2 theta. So that stops our video here. Thank you for watching and have a wonderful day.